is lesson 8.5, day 1, titled Trigonometry. We are going to go over this warm-up problem, which is a review from our special rate triangles we talked about in 8.3, which was like last Wednesday or something like that. Okay, who remembers like the little letters and their placements for 45, 45, 90 like we have in number 1 and 2? Alex? Perfect. She said the legs are both L. They're the same. And the hypotenuse is L root 2. Okay, so that's how I start these problems. I just label that. Then I see what's given to me, and here I see that L is 18. One of my legs is 18. What I'm trying to find is the hypotenuse. And since we know L is 18 and the hypotenuse is L root 2, X would just be 18 root 2. Okay, that one's pretty simple. All right, next one's another 45, 45, 90. The difference with this one is the variable, or what I'm trying to find, ended up being in one of the legs. And I was given the hypotenuse. So I know L root 2 is 42. So I just had a little extra step here to do a little bit of solving to figure out what L is. So I do this like an equation. Divide both sides by the square root of 2. And I get L is 42 divided by the square root of 2. But what's wrong with that answer? Can't have radicals in the denominator. Good. So I got to rationalize this by timesing the top and bottom by whatever the denominator is, which is the square root of 2. So that gives me 42 root 2 over the square root of 4, which is 2. And I can actually keep going here because I see this division problem. 42 divided by 2 is 21 root 2. That was basically given to me. Yeah, I had to do a little bit of solving to figure out what L is, but all that information was given to me. Then to find my variable, X is just whatever L is. So if L is 21 root 2, X would be 21 root 3. And I mentioned you could always check your answer by using Pythag. Those two legs squared should equal 42. There's some. Okay, 45, 45, 90s. Love those. So fun, like a puzzle. Who remembers the ratios for our other special right triangles, the 30, 60, 90? Tyson?
S.
Which is across from which angle?
Bottom was S.
Yep, the bottom one's S, so across from the smallest angle, which is the 30, is S. Okay, good, keep going.
The hypotenuse is 2S.
Hypotenuse is 2S, good.
Third side is S.
Across from the 60s, S root 3, good. Here, what's given to me is 2S. 2S, that doesn't say 25, that says 2S is 32. So I can easily figure out what S is. Divide both sides by 2. S is 16. And that's what you usually want to do is figure out what L or what S is. And then you just apply that to your other ratios. Sorry, I shouldn't say ratios. Your other side lengths. So X is just whatever S is. So X is simply 16, since that's what we just solved for. And then Y is just S times root 3. And since S is 16, we get 16 root 3. We could, again, check our answer with Pythag. We got some practice on this on the worksheet. You'll get more tonight with the book work. All right, another 30, 60, 90 here. So again, across from the smallest angle, which is 30, is S. Think S, smallest side. Across from the hypotenuse, 2S. Across from the 60, that obviously would be this one. S root 3. All right, this time I was given S root 3 is 10. Yeah. Gonna have to do a little bit of solving here for S. Oh no! Looks like we get radicals in the denominator again. That's okay, we're pros at this now. Rationalize. 10 root 3 over the square root of 9, which is 3. I can't simplify that any further because 10 is not divisible by 3, so we're just going to keep it as that improper fraction 10/3. Okay, we're not done. X is simply whatever S is. So X is 10 root 3 over 3. Y is double S. So 2 as a fraction, you can think 2 over 1. I want to double this. So that would just make 2 times 10 is 20. Root 3 over 1 times 3 is 3. Anybody 4 for 4 on those puzzles? Nice. Okay. Those are some special right triangles. We can find those missing side lengths. So if we don't have special right triangles, there is a way to find the missing side lengths in a right triangle, and it's by using something called trig ratios. Trigonometric. That's a long word to say, so you can just say trig. Trig ratios. I was so bummed because I was like so excited to teach this to you guys, and my 7th hour said that they've already seen this before. So, still gonna be just as fun, but just not as maybe new, but good review. All right, so I want to start off with these trig ratios are only applied to right triangles, and that's the chapter we're in right now. So only if you have a right triangle. So I have a right triangle pictured over here. I want you to label this triangle ABC, but I want you to use capital letters for angles because that's often the most common notation for these. So let's call this angle A. Let's call this one B. And then let's call the right angle angle C. Capital letters. Make them obviously capital. The other notation we use for the side lengths is across from angle A, we call that side A. And when we're talking about side lengths, we use lowercase letters. So this side across from angle A, that doesn't actually touch it, we call it side A. This side across from angle B, that doesn't touch angle B, we call it little b or side B. This is another one, you know, Pythag, a squared plus b squared equals c squared is my hypotenuse. Okay, so there are 3 of our basic trig ratios. They're called sine, cosine, and tangent. You guys heard of that before? Okay. These give us ratios of sides in our triangle, but it kind of depends on which acute angle we're looking at. So there's always obviously like these 2 acute angles in a right triangle. For sake of just this example, we're going to look at angle A. This angle right here. All right. We all know that the side across from our right angle is called the hypotenuse. So go ahead and write that in. I'll post these for you, Alex. The side that doesn't touch the angle, so in this case it's side A, we call that the opposite side. OPP, you can abbreviate it. Opposite side. Opposite means it does not touch the angle or doesn't form the angle. Now this third side, which it's not my hypotenuse, because it's not across from my right angle, it's not my opposite side because it's touching my angle. Anybody know what we call this one? Adjacent. Nice, Ben. Adjacent, which we talked about adjacent angles, and those are angles that are right next to each other. So this side is right next to the angle, adjacent. All right, for a minute here, if I was looking at angle B, do you agree that this would no longer be my opposite side? I'd be touching it. So it depends which angle you're looking at. So since we're looking at angle A for these, it depends, and your opposite and adjacent sides might be different depending on what angle you're using, okay? All right, so our first one we're going to talk about is sine. Sine of angle A, so how you notate sine is just S-I-N. It's not pronounced sin, it's pronounced sine. Okay, that's how you actually spell the word, but just abbreviate with the first 3 letters like we do for all of them. The side of the angle goes next, so since we're using angle A, we're going to do a capital A to represent angle A. Sine of A is a ratio, and this is just how it's defined, okay, and I'll give you a little like trick to remember this, is a ratio of the opposite side, I'm going to write the ratio as a fraction, to the hypotenuse. If I were to look at the letters, the opposite side is side A, the hypotenuse is side C. That's how our sine is defined. The sine of an angle in a right triangle is a ratio of the opposite side to the hypotenuse. You guys heard us? SOHCAHTOA? SOHCAHTOA. So the OH in SOHCAHTOA, O stands for opposite, H stands for hypotenuse. So that's how you can remember sine is a ratio of your opposite to hypotenuse. Okay. Our next friend is cosine. Cosine we abbreviate as COS. We're still going to use angle A. So every time you write a trig function, you have to have an angle after it, and make sure you use capital letters, unless otherwise noted. Cosine of an angle in a right triangle is a ratio of the adjacent side to the hypotenuse. And that's where the K comes from, C-A-H. So in this case, the adjacent side is side B, to the hypotenuse is side C. Okay, that'd obviously be a different ratio. And our last one is tangent. And then again, we just take the 3 letters in the shorthand notation. So we just do T-A-N. You don't say tan of A. It's still pronounced tangent of A. It's like one of my pet peeves when people say tan. And tangent is defined as a ratio of the opposite sides. This is where the TOA comes into play. OA, opposite side to the, what do we think? A, adjacent. Bingo. Okay, want to know a fun fact? So A to B. So if you're thinking in your head, maybe you are, maybe you're not, but if you're thinking in your head, well, what about a ratio of the hypotenuse to the opposite side? We don't have a ratio defined for that. Or what about the hypotenuse to the opposite, or even adjacent to opposite? Because that's a different ratio than opposite to adjacent. There are actually 3 other trig functions that exist, but don't worry. You don't have to know those in geometry. You'll learn those if you ever take pre-calculus. And pre-calc, 75% of our whole year is like trigonometry. So fun. But there are more that exist, and you guys just have to know these basic 3. SOHCAHTOA, write that down, SOHCAHTOA. That is important. Okay. Let's try some. So here I have a right triangle, one of our Pythagorean triples, and I'm given all the side lengths. The directions tell me to find the sine of angle L, the cosine of angle L, tangent of angle L, those capital letters are standing for angles, and then the same for angle N. It says express each ratio as a fraction and as a decimal to the nearest hundredth. Okay, so first let's do angle L. So go ahead, take angle L and just maybe mark it with like an arc. So I like to do a little template for myself. I need to find the sine of L, cosine of angle L, tangent of angle L. I'm gonna write SOHCAHTOA down because it helps me memorize it. And then it's easy to kind of plug in my numbers because I know the ratios. Okay, so let's write it as a fraction, so we'll do that first. If I'm looking at angle L, and since all of the sides are labeled with numbers, you can just shout out the number. Which of these 3 sides would be my opposite side? Do we agree? 12? Opposite is not touching. Good. What's my hypotenuse? 37. 37 is my hypotenuse. Sounds the easiest to detect across a right angle. meaning my adjacent side is what? 35. All right. Do I know what the measure of angle L is? I know it's not 45, 45, 90, because otherwise the legs would be the same. We don't know what it is, and we don't have to find out. Okay? They just want us to write the ratios, and we know all the side lengths. So for sine, it's a ratio of the opposite, which is 12, to the hypotenuse, which is 37. You should simplify these ratios if you can. 12 over 37 cannot be simplified. It did ask us to also write this as a decimal, so if I take 12 divided by 37, that's 0.34. Round to the nearest hundredth. Okay. Cosine of angle L. Cosine is adjacent, a ratio of adjacent to hypotenuse. There's my ratio. Can't be simplified. So as a decimal, that's 0.95. Tangent, opposite, 12, to adjacent, 35, or approximately 0.35. All right, there's my first list. Now I have to do the same for angle N. All right, so that's going to switch up some things. Does it change which side is my hypotenuse? No, my hypotenuse is still 37. But what it does change is now 35 is no longer my adjacent side. 35 is now what side? The opposite. Good, because it's not touching it. So this is going to switch up. So you can either just kind of like cross off what you just wrote or erase it. This is now my opposite side. It's not touching the angle. And now 12 is my adjacent side when I'm looking at the acute angle N. That doesn't change up how sine, cosine, and tangent are defined. They're still defined as those same ratios. But now you'll notice that I'm going to get some different ratios if I'm looking at angle N. All right, sine, opposite, which is now 35, to hypotenuse, which is still 37. And you're like, oh, weird, that was the same as that what we got for cosine, which makes sense because the only thing that flip-flopped was the adjacent and opposite sides, right? So that one's going to be 0.95. That will happen every time, folks. So then cosine is adjacent, 12, to hypotenuse, 37. So 0.34. All right, tangent, opposite to adjacent, 2.92. Tangent is the only one that can actually be greater than the number 1. Because your hypotenuse should always be the largest side. And tangent doesn't have a hypotenuse in the ratio. So depending on which side's bigger, the opposite or adjacent of the two, tangent could be greater than 1. All right. Ooh, these next problems are really fun. It combines what we talked about in 8.3 with SOHCAHTOA. It says, use a special right triangle to express each trigonometric ratio as a fraction and as a decimal to the nearest hundredth. Oops, I forgot to do this as a decimal. Oh well. All right. So if I want to find the tangent of 30 degrees, this time they're telling me what the angle measure is. It's 30 degrees. So they said to use a special right triangle. So go ahead, draw a right triangle. Doesn't matter how you draw it. But if I want to know 30 degrees, I'm like, okay, that would come from my 30, 60, 90 special right triangle. So again, it technically doesn't matter where you label this, but just for sake of us doing it together, let's put 30 degrees down here and 60 degrees up here. Okay. We did this in the warm-up. The ratio for 30, 60, 90 across from 30 is S, 2S, S root 3. You guys got that memorized yet? Hope so. All right, so what they want me to do is they want me to take the tangent, so tangent is TOA, of the 30-degree angle. So they want me to use this angle right here. Tangent is opposite, which is S, a ratio of the opposite to the adjacent. Okay, so the tangent of 30 degrees. Now, the only difference with this one is now I actually know what the angle measure is. So I'm going to write that in instead of just calling it like angle A or something like that. The tangent of 30 degrees is the ratio of the opposite, which is S, to the adjacent side, which is S root 3. And you're like, okay, this looks kind of weird. What is S over S reduced to? 1. Anything over itself is just a big old 1. This is a big old 1. So I have up top, I have 1 over the square root of 3. And what's wrong with this answer? Can't have radicals in the denominator. Got to rationalize. So the tangent of 30 degrees is the square root of 3 over the square root of 9, which is 3. Okay, so in our calculator, we have to take the square root of 3 divided by 3 to get this decimal. So how we would do that is we'd hit second. This button right here is the square root. So the square root of 3, close that, and we want to divide that by 3. So you should get this decimal. So 0.58 would be run to the nearest digit. Okie doke. There's the first one. The next one wants us to find the cosine of 45 degrees. So if I use a special right triangle and I want 45 degrees, I'm going to draw my 45, 45, 90. Maybe let's draw a triangle this way this time. Doesn't matter. 45, 45, 90. All right, so they want me to find the cosine of 45 degrees. I have two 45 degrees here. And if I do my little L root 2, I know no matter which one I pick, my adjacent and opposite side are both L. So it doesn't matter which one you pick. Let's say we pick the top one for this one. Let's say we pick this angle 45. If I want to find cosine, so that helps me figure out which ratio it is. The cosine of the angle we're using is 45 degrees. Is a ratio of my adjacent side. So if I use that angle, this would technically be my adjacent side, to my hypotenuse. All right, so my adjacent side is L to my hypotenuse, which is L root 2. Okay, similar setup here. That's just a big old 1. So you get 1 over the square root of 2. Rationalized. Cosine of 45 degrees is square root of 2 over 2. As a decimal, same thing. Take the square root of 2, close that, divided by 2. I think it's like point, I'm just doing this for memorization. Is it like 7.1? It's like 707. Is that right? Okay. The reason why I know that is because in pre-calc we use these ratios all the time. So I see those numbers pop up a lot. And you will too eventually. Okay. So guess what? Our calculator can do this for us. If you look at your calculator, you should see 3 buttons that say sine, cosine, and tangent. So let's try to type this one in our calculator right here. Type in the tangent of 30 degrees. One thing. See how this calculator on the sheet says RAD in the bottom corner? Your calculator should say DEG. DEG right here. Does anybody say RAD? Yours says? I gotta switch it. Why is yours say this one?
No idea.
Okay. All that means is we're measuring our angles in geometry. They're always going to be in units of degrees. DEG. RAD stands for radians. You don't do that till pre-calc if you take that. All right, so in our calculator, let's see. So there's what the square root of 3 over 3 is, right? It's that big long decimal. So if I type in the tangent of 30 degrees and close that, I get that square root of 3 over 3. The problem with this is your calculator is never going to give you that exact value. Your calculator, unfortunately, is not going to give you the square root of 3 over 3, but it'll give you that decimal, that 0.58, right? That was the same decimal that we got when we did the square root of 3 over 3. Yes, sir. Exact. Yeah, you're not supposed to be using that calculator. It's okay. I'll fix it for you. I know how to change it. No, I will. Let's try this one. The cosine of 45 degrees. Let's try that. Cosine of 45 degrees. Was that the same decimal that we got for the square root of 2 over 2? You betcha. So your calculator can do this, but unfortunately, your calculator will only give you the approximation. All right, so what I want you to write in your notes next to these calculator ones is these buttons are used when you know what the angle measure is. All right, you need to take the sine, and then what goes in parentheses is the angle that's measured in degrees. Okay, same for cosine, same for tangent. Because do you see those little buttons above them that look like sine, cosine, and tangent, but they have like a negative first power? These ones? Those are used for something different. We'll talk about those in a minute. But what I want you to know is the number that your calculator is giving out to you, the answer, it is the ratio. So if I'm talking about sine, and I take the sine of 15 degrees, it's going to give me out the ratio of the opposite side to the hypotenuse, but it's going to do it in decimal form. Okay. But we need to use our calculators for some of these problems. We're going to try a couple in a minute. So anytime you're using those buttons, what you type in after sine, cosine, and tangent is the angle measure. And what you get out is the ratio. All right. Let's try one. A fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Let's show you right here. Approximately how many inches? This is measured in feet. We want to know inches. Okay, keep that in mind. Did the trainer raise the end of the treadmill from the floor? So they're marking that with Y. Agreed? This would be the floor. How many inches did the trainer rise the treadmill to get 7 degrees? All right, so what's given to me is the length of the treadmill. And looking at this right triangle, that would be my hypotenuse. Agreed? It's across my right angle. You always, whenever you're trying to find a missing side length, I can't use my special 45, 45, 90, 30, 60, 90 ratios because this isn't a 30, 60, 90 or 45, 45, 90, right? I have 7 degrees. So you always want to use the information given to you. So you're given the 7 degrees, you're given the hypotenuse, and then I'm trying to find what side, the opposite or the adjacent? Opposite if I'm looking at 7 degrees, right? Opposite. So then I'm looking at my 3 SOHCAHTOA, my 3 trig ratios. And since I know the hypotenuse, I'm not going to use tangent because that doesn't even have a hypotenuse in it. I know the hypotenuse, and I want to find the opposite side. So which one would I use? So, because that one has opposite in it, right? I'm going to use sine here. That's usually the hardest for students to decide which trig function do we use. Depends on what's given to you and depends on what you're trying to find. So we would set this up as the sine of the angle, which is 7 degrees in this case, is equal to the ratio of the opposite side, which is y, to the hypotenuse, which is 5 measured in feet. Okay, now think of this as like an equation. My variable's on the right-hand side, and my variable's being divided by 5. How do we undo divided by 5? Multiply by 5. Those are inverse operations. They undo each other. That would get rid of this. I'm going to go ahead and just put y on the left-hand side. So y is the same as 5 times the sine of 7 degrees. So I'm going to type that in my calculator. 5 times the sine of 7 degrees. And you can type this all in once. 5 times the sine of 7. Just make sure your angle is the one in parentheses. Okay, this doesn't say 5 times sine times 7. This says 5 times the sine of 7 degrees. Okay, you should get this. Now, my issue with this answer is this is going to be in feet, because this is measured in feet. So, my calculator tells me round to nearest hundredth. That's in feet. And they're asking how many inches. Well, folks, how many inches are in 1 foot? 12. So we just got to times this by 12 inches. Convert it to inches. So I think I got 7.3. You won't have to do that on all of them. I just wanted to do one like that together where the units don't match. Yes, sir. It's an RAD. Okay. Oh, now you're in. There you go. I guess I could show you guys how to do that in case it ever happens to you. So, if you hit this button, DRG, that means degrees. So you can just like use your arrows. So if it ever does get in rad mode, just hit this and you want to tab over to DEG and hit enter. Now it's in degree mode. Okay, let's try another one. All right, this time I want to find X, and they just said round to the nearest hundredth. And the angle given to me is 70 degrees. Now, I know you guys could all do 180 minus 90 minus 70 to find the other one, but use the information given to you. It makes it a lot easier. All right, so if I'm looking at 70 degrees, this time I'm given which side? Adjacent. Good. Adjacent side. I don't know my hypotenuse. I don't know my opposite. I'm trying to find my hypotenuse. So from my SOHCAHTOA, which of these three would I use in this case? Cosine, because I know the adjacent, so that eliminates sine. I know the adjacent, and I want to know how hypotenuse. This one doesn't have hypotenuse in it. All right, so how I would set up this is the cosine of the angle, which is 70 degrees, is equal to the ratio of the adjacent side, which is 15, to the hypotenuse, which is x. Okay, this one's a little different to solve. X is on the bottom this time, so I can't times both sides by 15. I actually got to times both sides by x, because that would undo dividing by x. And then I have x times the cosine of 70 degrees is 15. With me? Now, picture if this was like x times 7 equals 15. How would you solve in that case? We would divide by 7. So here I'm just going to divide by the cosine of 70 degrees. I would get rid of this. And this I can type in my calculator. I can take 15 divided by the cosine of 70 degrees. We're going to round here, so I'm using my approximate symbol. All right, in my calculator, I would take 15 divided by the cosine of 70 degrees. Remember, the angle is what goes in parentheses, and close that parenthesis. Okay, you should get 43.86. We'll round that too. It should kind of make sense. Obviously, the hypotenuse should be your longest side, so that's definitely larger than 15. I don't know what my other side is. I could find my other side if I wanted to by using Python, or I could set up another trig ratio. It doesn't ask me to do that though, so we'll stop there for x. Okay, I just want to talk through one more thing. We won't finish all these notes, but that's okay. We just have a few minutes. Oh, sorry. Okay. Now, going back to those little buttons you saw on your calculator that look like this. Sine with like a negative first, like in the exponent spot. Cosine with a negative first in the exponent spot, and tangent. That notation means inverse. Okay, inverse in math can mean a couple things. So like inverse operations would be like adding and subtracting because they undo each other. Multiplication and division. So sine and inverse sine kind of like undo each other. So what these buttons are for is if you know what the ratio is, so if the sine of some angle is this ratio, then I can use the inverse sine and it'll tell me what the angle is. Another way to talk about inverses, and you'll get to this in algebra 2, you'll talk a lot about inverse functions, is you switch their inputs and outputs. Okay, so for sine, we put in an angle, we get out the ratio. So for its inverse, we put in the ratio and it feeds out the angle. All right, so same for all of these. So last thing I want you to do, write this, that these inverses are used to find the angle measures. And then I want you to go back quick to that calculator page, this one. So these ones use sine inverse. You put in the ratio. Okay, obviously this is the same for all these. And your answer that comes out is the angle. See the difference? Okay, we're going to try one of these. Plus, we don't need to line up because a lot of us like to leave early. And that makes Mrs. Reynolds mad. And disappointed. Okay, so let's try one of these in our calculator. So we got the cosine of 45 degrees. We got square root of 2 over 2 for that ratio, right? Remember that? We got that the cosine of 45 degrees is square root of 2 over 2. So let's take the inverse of the ratio. Let's take the inverse cosine. So you hit second cosine of the ratio, which is square root of 2. Close that. Divided by 2. Close that. All right, I'll let you type all that in. So take the inverse of the ratio. Head up. And what should we get out?
45.
We should get out the angle. Hit enter. Did you type in exactly like me? With the parentheses?
Oh.
45 degrees. It'll tell you the angle that gives you that ratio. Sorry, I should say a lot of us like to leave early. Some of us like to leave early. Not the majority.
Not
Okay.
finger.